Anybody else who has done question? Thank you. Anyone else? All right, guys. So yes. Yesterday we started on portfolio theory, which falls under the second half of the course. Remember, there are two halves to this course. The first one is called extreme values. The second one is called financial risk, right? And this part of the course falls under financial risk, right? Okay. So let me just run through what I did yesterday. I know. So a portfolio is a collection of investments. So for example, investments on gold, silver, and copper. That could be a portfolio. Or investments on different properties. That could be a portfolio, right? And then I introduce some notation. Let n denote the number of investments in a portfolio, and x1 to xn denote the losses on the n investments, right? So these are stuff I did yesterday. So if you were not here yesterday, you can find this online. You can find these guys online, okay? Okay. Then I talked about there are 6 possible cases in reality, right? And the 6 cases are these ones here. So the first case one is where the losses are IID, random variables, and n, the number of investments, is fixed, and so on. And the last case is where the losses are dependent random variables and the number of investments is a random variable. There are 6 cases to consider, right? And then I talked about 3 different variables that are of interest, A, B, and C. A is the total portfolio loss. B is the minimum portfolio loss. In other words, the investment that is least costly, or in other words, most profitable. And C is the maximum portfolio loss. In other words, the investment that is most costly or least profitable, right? So these are 3 variables of interest, right? Okay, and then I considered case 1. So the purpose here is to derive the distribution of the 3 variables S, U, and V for the 6 different cases. So I started with case 1, right? And in this case, the CDF of S can be written like this, right? This can be written like this, the CDF of total portfolio loss, and the PDF of S can be written like this. Okay. And then I did an example. I did an example where the number of investments is 2, and in this case, the CDF can be written in this form, and the PDF can be written in this form. Okay. And then I computed the CDF of U, which is the minimum portfolio loss, which turns out to be this, right? And the PDF of U turns out to be this, right? And then I computed the CDF of V. Remember, V is the maximum portfolio loss, and it turns out to be this, and the PDF turns out to be this, right? That's case 1. Then I did another example number 2, where I considered x1 to xn to be IID normal, and in this case I showed that the CDF of S is given by this, and the PDF of S is given by this, right? And the CDF of U is given by this, and the PDF is given by this, and the CDF of V is given by this, and the PDF by this. Okay. and that's example number 2. Then I did example number 3. This is example number 3 I did yesterday. Here I assumed that the losses are IID exponential with parameter A. In this case, it can be shown that the S has a gamma distribution with parameters N and A. The CDF is given by this, where this little gamma is known as the incomplete gamma function defined by this, and the PDF of S is given by this, right? And the CDF of U is this, the PDF is this, the CDF of V is this, and the PDF is this. So those are 3 examples I did on case 1. Then I started with case 2. So to do case 2, you need to use the total probability rule, right? Okay, you need to write the probability that S is less than equal to S as the sum of the product of these 2 probabilities. This is the conditional probability, and this is the probability of N. Remember, N is now a random variable from 1 to infinity, right? So it turns out that your CDF is given by this, and the PDF is the derivative. Okay, and the CDF of U is given by similar argument. By similar argument, the CDF is given by this, the PDF by this. And again, by similar argument, the CDF of V is given by this, and the PDF by this, right? And finally, I did an example. This is example number 4, where x1 to xn are IID with n. N is a geometric variable with parameter A. And I showed you how to derive the distribution function of U. Turns out to be this. And also the distribution function of V, which turns out to be this. Right? You guys have any questions so far on what we did yesterday? Yes? No, guys? I mean, feel free to ask me, because I really want to help you guys. Yeah. Are you guys okay? Do you have any questions? Was it clear, or everything we did yesterday? Yeah. Yeah. Okay. So, by the way, the tutorial from 5 to 6 today it will be next door. It will be based on the problem sheet I gave you yesterday. This is the problem sheet. Do you have a copy of this? I gave it to you yesterday, right? Oh. You got one?
Go on with it, thank you.
Okay, thank you. So, you are okay, so over to you. Sorry, man. Okay, guys. So we will go through that problem sheet in the next hour from 5 to 6. Okay, but before that, let me carry on with case 2. Now, this is example 5. Okay. Right, so here we have x1 to xn id with the distribution n given by this, right? And we want to find the distributions of u and v. Remember, u is the minimum portfolio loss, v is the maximum portfolio loss, right? Okay. Okay, now you should use the formula that I gave you yesterday. So let's start with u. The CDF of u will be do you guys remember the formula I gave you? I'm sure you do, right? It's like this. You can look it up if you want. Alright, this is the form. You should look at the formula I gave you guys yesterday. Just trying to find out. I mean, if you look up in the notes, you will see it. Yeah, it is. It's this one here. Oh, not this one. That's for case 1. Case 2 is this one here. This is the formula I gave you yesterday, right? So I'm using this formula to write this down. Okay. Now you can write this as okay, you can write this like this. Now in the next step I'm going to make a substitution. I think you can guess what it is. I'm going to make the substitution m equal to n minus 1. Yeah. So this will become, this you can simplify it to I left out something. Excuse me. Just a minute. There's an n factorial here I left out. There should be an n factorial here. Okay. Right. Wait a minute. You can do it like this, but it will be easier if Can I start again? Sorry, I mean, can I start again, please? Okay, sorry about this. I think I made a mistake. I mean, I think I shouldn't have done it like this. sorry, can I apologize. Let me start again, okay? I apologize for this. Example 5. So suppose okay, so you start with this, which is 1 minus the sum from n equal to 1 to infinity. I apologize for messing this up. Okay, all right, and then this thing here, you can write it like this. You can write this as 1 minus e of minus a divided by this, and you have n from 1 to infinity of like this. Okay, now there is a result. I don't know whether you know that. I'm sure you, I mean, some of you may know this, but if you have something like sum from n equal to 1 to infinity of z to the power n divided by n factorial, this is equal to e of z minus 1. I mean, do you guys know this result? This is basically the Taylor series expansion of the exponential, but without the first term. Do you know this result or not? Yes. So this sum is equal to this, right? So that's what I'm going to use in the next step. So if you use that, you get 1 minus 1 over so this is the CDF of U, the minimum portfolio loss, right? Using this result. Is that clear? Yeah. Okay. All right, guys. Okay. Let me put this over here. Okay. The next thing is to find the CDF of V. To find the CDF of V, once again I'm going to use the formula that I gave you yesterday, right? If you look at the notes, this is V. Okay, this is what you get, and this you can write as follows. Like this, right? Now once again using this result, which I'm going to write again. So the result is that you should use this result, guys. Okay, you will get the above can be simplified to the following. Sorry, why I'm doing this? Right, sorry, just a minute. There should be a -1 here missing. Sorry, let me sort this out first. I left out a -1 here, so this should be -1 here. I mean, because I'm using this result, so I need to take the exponential of this and subtract -1. Sorry about this. It's the same here. Okay. Alright guys, is that because I'm using this result, guys, so the sum of this must be the exponential of this term minus a 1 outside, right? So and the same thing here, using this result, this sum should be exponential of this -1. Okay, so that's the example number 5. Any questions on this so far, guys? Yeah, you okay? Everybody up again? Sorry, I forgot to give you the attendance sheet. The attendance sheet, where is it? Trying to find the attendance sheet. Sorry, just a minute. Just give me a sec, guys. Alright guys, so are you okay with this? Yeah? Okay. Right. The next thing I'm going to talk about is case number. So we've done case 1 and 2 so far. So obviously the next case to look at is case case 3. So case 3 is where x1 okay. So case 3, remember, is where x1 the losses are independent but not identically distributed, and n is the number of investments is fixed, right? So in this case, I'm going to derive the distributions for S, U, and V, right? S is the total portfolio loss, U is the minimum portfolio loss, and V is the maximum portfolio loss. So starting with S, the CDF of S, you may remember in case 1, let me go back to case 1. This is case 1. We did this yesterday, right? And this is the formula that we got for the CDF of S, right? But in this case, it's going to be different because of the fact that the variables are not identically distributed, right? So it's going to be going to be like this, right? And because the variables x1 to xn are different, they're not the same, right? You can't actually simplify this further, right? Okay, so you have to leave it like this. So you have to say that this So this is the formula for the CDF of S, right? And the PDF of S PDF of S is this, just the derivative, okay? Alright guys. Alright, now I'm gonna do one example before I go ahead. So this is gonna be example 6. Suppose n is 2. Can you read this? Yeah. Okay. Then the CDF of S will be this, okay? You guess what? I'm just using this formula here, okay, to get this, right? So this will be because what you have here is actually a double integral of Now, if you look at this integral here, guys, if you look at this, the thing I have circled in red, right? What you have is the CDF of x2, right? So what you have here is simply the integral of fx1 x1 fx2 so this is the formula for the CDF of S when n equal to 2. You can't simplify this further because x1 and x2 are different. They are not the same, right? So you have to leave it like this. Then the next thing is the PDF. To find the PDF, you just simply differentiate this. You should differentiate this, you get alright. So this is the PDF of S when n equal to 2. N equal to 2. Okay. Okay, guys. Right. The next thing I'm gonna do is to find B the CDF of U, right? And this you can write as 1 minus the probability that capital U is greater than little u, right? Okay, and this okay. Now if the minimum is greater than u, then each element has to be greater than u. Alright, so this will be right. Alright, and in the next step you can write this as this is because of by independence, right? Okay, now I'm going to write this as like this, and this will become 1 minus like this, and this would be 1 minus the product I from 1 to n of 1 minus f x I at u. All right, so this is the formula for the CDF of U in case 3, right? You see, this is different from what we had in case 1. In case 1, we had a different formula, right? You may remember. Okay? Right. The PDF of U, so you need to differentiate this. So it's gonna be the derivative of this. Now, what do you think the derivative will be? This is where your product rule comes in. I'm sure long time ago you must have done in your calculus course. You must have done the product rule, right? No? You didn't do it? Come on, guys. Don't tell me you didn't do it. Right, this follows by the product rule for differentiation. Did you? I mean, you must have done this long time ago. Like if you apply the product rule for differentiation of n functions, if you differentiate that with respect to U, this is what you will get. Come on. This is easy when you have two functions. It's easy, but when you have n functions, it's more difficult. Right. Let me do just an example. Like say example. This is what example 7. Okay. Suppose n is 2, right? In this case, the CDF of U this is U. Okay, this is your CDF of U, right, when n equal to 2. So if you simplify this will be F this is what you get. Alright, and the PDF of U is just the derivative of this, so it's gonna be, you should differentiate this with respect to U, you will get F right? So this is easy because here you just apply for you only need to apply the product rule for this term here. You only have two terms, product of two terms. So it's just a simple application of the product rule. But in general, in the general case, you have to use the product rule for product of n functions, right? Which is what I have done over here, right? Yes, the product rule for the product of n function. Okay. All right, guys. So let me put it here. Hopefully you can see this. The next one I'm going to do is C, which is the distribution of V. Right? V is the maximum portfolio loss. Right? So the CDF of V this, and this is the probability that the max of x1 to xn is less than or equal to V. So V, right? So if the max is less, then each has to be less. Now, using independence, you can write this as this is by independence. Okay. All right. Now what you have is fx1 at V multiplied up to fxn at V. Okay. So this will be I from 1 to n. Like this. Okay. So this is the formula for the CDF of V in case 3. Okay. Now the PDF of V so again you need to apply the product rule to do the PDF, to find the PDF. Alright, so I'll show you in a minute. So if you apply the product rule, this is what you will get. You get I from 1 to n, little f xi v, and the product j from 1 to n of f xj v, and j not equal to I. Alright, so this is once again I have used the product rule for differentiation, right? Alright guys, any questions so far? Yeah, okay. Alright, so that's CDF for V. The next, I'm going to do an example. Example 8. Suppose n equal to 2, right? In this case, the CDF of V is this, right? It's just the product of the two CDFs of x1 and x2. And the PDF of V is just the derivative of this, so if you differentiate this with respect to V, you will get the PDF. So it will be okay, so this is the PDF of V. Alright, it's a simple application of the product rule, gives you the PDF. Okay guys, that's example 8 over here. Next one, I'm going to do well, I've got a couple of minutes left, so let me do just one example. Example 9, one more. I may not be able to finish this, but right, starts with A. A is let me ask you, this is where your statistical methods comes in. I know some of you guys did statistical methods last year. What distribution will this have? With what parameters? It will be normal with parameters you must have done, you should yeah, you remember this, right? Okay, so the CDF of S is is this, right? Where is 0, 1, and the PDF of S is just the derivative of this, which is right, guys. Do you see what I've done? Right, so I'm sure all of you know that the sum of independent normal is normal, right? And therefore the CDF is this and the PDF is this. Capital phi denotes the standard normal CDF and little phi denotes the standard normal PDF, right? Right? Okay, now just bear with me. I'll give you some chocolates, so don't worry. You guys okay? I know after I do this, I will give you a 10 minutes break, so don't worry. This is A. Now B, listen guys. The CDF of U do you remember the formula I gave you for the CDF of U, guys? Or you forgot already? What's the formula I gave you for the CDF of U? 1 minus, okay, there we go. So it's gonna be phi of U minus mu I divided by sigma I. Okay, this is the formula I gave you, right? Now this actually you can simplify to